International Conference on Communication, Electronics and Digital Technologies, NICEDT 2023. I would request our esteemed dignitaries, our DG Dr. M.M. Tripathi, Professor S.N. Singh, Dr. Yahya Al-Marzuki, Professor K.K. Agarwal, and Dr. M.P. Pillai and Dr. Y. Jayanta, Yumnam Jayanta, to please come on stage and take their seat, please. Dr. Pillai, Dr. Jayanta, please.
This meeting is being recorded.
Our dignitaries had taken their seat on the stage. All the esteemed authors who have joined us, my seniors in NICEDT, my colleagues, and my dear friends. NICEDT's International Conference on Communication, Electronics and Digital Technology is the first of its kind in NICEDT. We didn't have this thing any time before. This international conference will focus on sharing research and developmental outcomes in ICT and related areas in form of original unpublished papers that our various authors have submitted, which have been published in Springer and also in our International Journal on Digital Technology, and also to strategize on preparing a global future-ready workforce, which is one of the key themes of DWG G20 presidency year for India. So without much ado, I'd request Dr. M.P. Pillai to felicitate Professor S.N. Singh, Director, Atal Bihari Vajpayee, IIIT Gwalior, with a bouquet of flowers. I request Dr. Yumnam Jayanta ji to please felicitate Dr. K.K. Agarwal, ex-Chairman, National Board of Examination. I request Dr. M.M. Tripathi to felicitate Dr. Yahya Muhammad Sharif Al-Marzuki from Tawazun Council, United Arab Emirates, Abu Dhabi. And as part of tradition in India, I would once again like to trouble our dignitaries on stage to please step down for a couple of minutes to light the ceremonial lamp and invoke the blessings of Almighty. Please. So, ladies and gentlemen, we'll start the proceedings, and I would request our very erudite Dr. M.P. Pillai, Executive Director, NICEDT Calicut, and also the General Chair of this conference, to welcome the dignitaries and the august gathering. Dr. Pillai, sir, please.
A very much good morning to all. At the outset, I'd like to extend a warm welcome to you all to this inaugural session of this first NICEDT International Conference on Communications, Electronics and Digital Technologies. On behalf of the management of NICEDT in general, and as a chair of this conference, it's my proud privilege to provide this welcome address. This is the first international conference organized by NICEDT as a whole. This has created a great opportunity, not only for the researchers across, but also for the stakeholders of NICEDT. This is evident from the great enthusiasm and involvement shown by young scientific staff and students of NICEDT. It's a kind of a technical get-together of NICEDT family. Day 2 has been dedicated exclusively for digital skilling, which is in line with the Government of India initiative, as well as a lead event for the G20 presidency year. So before proceeding to the formal welcome, I would like to provide a gist of this conference, being one of the chair. Providing equal opportunity to all researchers across various IECT areas, latest domains were identified and accordingly invited to present papers broadly in the areas of computing, ESDM, digital technologies, as well as digital skilling. Our call for paper received overwhelming response and resulted in 152 full-length papers from academia, research, industry from around the world. All submissions were extensively reviewed by internal as well as external committees before allowing to present. Finally, from the 152 initial submissions, 50 papers were selected for publishing in lecture notes of Springer, and 18 in our own IJDT journal. A total of 68 papers will be presented in the conference today. In addition, 10 invited talks through renowned experts, they are present here, from academia and research across the globe is also scheduled. I hope participants find this conference stimulating and thought-provoking. On this great occasion, we are happy and fortunate to have authorities from relevant domains with us today to enlighten us through their experience and expertise in respective areas. The chief guest of this inaugural program, Professor K.K. Agarwal, the Chairman NBA, the authorities which ensures quality and standards in higher education, we all know in this country. He was also Vice Chancellor, GGS Indraprastha University, and former President IIT. It's our privilege to have you here with us, sir, as a chief guest. I extend my warm welcome to you on behalf of the management and the organizing committee. Also, our guest of honor, Professor S.N. Singh, Director, IIIT-M, Gwalior, a Humford Fellow. I had mentioned this. Has wide experience as Professor IIT and actively involved in IEEE activities. Our heartiest welcome to you, sir. Professor Rajkumar Bhuiya, University of Melbourne. Doesn't require much introduction, founder of Indian Parallel Processing and Supercomputing Initiative in this country in the 80s. He would be joining and delivering the lecture through virtual mode. We would like to welcome him also. Dr. Yahya Mazuri is the Executive Director and is also the Chairman of Engineering Innovation Solutions UAE Center. He's a board member of UAE University. Is here with us to deliver the speech. A warm welcome, and we are eager to listen to you, sir. Dr. Madan Mohan Tripathi, DG NICEDT and President of this event. He is our source of inspiration and the man behind this conference. Though NICEDT unit organizes such events at center level, it was his suggestion immediately after taking charge as a DG to take it as a single mega event. On behalf of organizing committee, And as a chair, we extend our warm welcome to you. In a short span of assuming the responsibility, DG NICEDT, he could make this happen today. Thanks for all your support and cooperation. I welcome all invitees, my colleagues from different NICEDT centers, participants, others, media persons to this event. Welcome, and a couple of experts are here. I extend warm welcome to all the speakers and invited guests here. Once again, I extend my warm welcome to you all. Thank you.
Thank you, sir, for the wonderful welcome speech, and it is so heartening to know that NICEDT conference in its demo has scored a century, and that to a century and a half. And that's really commendable, going by the standard and going by the time that we had. This is really very commendable. Thank you, sir. Thank you for your words of welcome. Now, I would request our respected Dr. Madan Mohan Tripathi, Director General, NICEDT, because today this conference is because of his vision and guidance that we are have all aggregated here. We have all come over here and doing this conference. Sir, over to you for doing the presiding speech, sir, please.
A very good morning to all of you, and I welcome all the dignitaries and my colleagues and the participants in this conference. This is the first version of this type of conference in NICEDT. I welcome Professor K.K. Agrawal. We all know he is the founding Vice Chancellor of the IP University and Chairman NBA and President IT. But I don't know that today NICEDT fraternity knows or not that he was the last academic chairman of the Governing Council of DOACC. So let's welcome with great applause. And then DOACC is today's NICEDT. Sir, I welcome you. Professor S.N. Singh, in country everybody knows him. His research credentials are of highest standard in the world. He is a professor of IT Kanpur and currently director of IIIT Gwalior, and former vice chancellor of Madan Malviya University of Technology, and my PhD guide also. So I welcome you, sir, here. Dr. Yahya Al-Marzuki is a great friend. I'm really happy that you traveled from UAE, and you are busy. I know your schedule is busy, and at the last moment even you have been given some assignment and it was very difficult for you to come. Still you traveled to India. So we are very happy to find you here among us, and we'll be discussing many other things on the sidelines of the conference also with you. Dr. M.P. Pillai, my senior colleague, most executive director of NICEDT, who is the general chair also, and Dr. Jayanta Singh, the general chair. All other the team. Today we got a lot of praise from all the dignitaries that the kind of show NICEDT has put up today at one place, where we can see all the initiatives taken by NICEDT, which is so diverse in the country, ranging from digital literacy to high-end training in the emerging technologies and future skill technologies, and to product development. Very less number of organizations in the country will have that kind of wide variety of areas where they are working. I mean, somebody may be doing very good in the research and skilling, somebody is doing in entrepreneurship and startup, but NICEDT has a single place. We have so many diverse kind of working that may range from the data collection of 62 crore citizens of NPR to the agri-census, and then developing a lot of intellectual properties while in electronics, and then skilling in the forefront. And we all know that we have the biggest number in the skilling in the country, around 10 lakh people every year we skill in the country. It's the highest for any organization. But one thing was missing in NICEDT. Our academic face was missing. And that's why we thought of this conference. Through this conference, every year will be, since it is a rotating conference, next year it is in Guwahati, and then it will be moving to different centers of the NICEDT. This will probably become one of the biggest brand of NICEDT in the academic arena, because we are also going to be a university very soon. So our academic perception is also very important. So for building a perception for NICEDT, this conference was very much important. And the second good thing is happening, that our team has made a lot of effort to launch the first journal, International Journal of Digital Technology, and let me tell you, it is the first journal in the world in digital technologies. And hopefully that will also become one of the very prominent journals in future. So we are starting today, but in few years, with the blessings of our seniors who are sitting here and all other members of the NICEDT, I'm sure this is going to be one of the most reputed journals in future in the whole world. So digital technologies, as we know that if you go by definition, that is the advanced applications of ICT. That is called digital technologies. So digital technologies are used in the world in a different names like ICT, IECT, IT, and so many words are there. But first time the digital technologies word is coming up, and it is combining all kind of efforts. So that's why the International Journal of Digital Technologies will cover every aspects of the electronics, IT, and related areas of the technologies that will cover, and that will come under one umbrella of digital technology. So that was the reason also to coin this word, International Journal on the Digital Technologies. And if you see the tracks, the 8 tracks are also designed in to cover different aspects of the digital technologies. And we have a very special track due to our concerns to the society. We have a track, the digital technologies for Divyangs, which normally people don't have. So we dedicated a special section also for the Divyangs, because we want to support and promote research in and technology development in these areas also, because for an inclusive growth of the societies, it is very important that all the technical organizations work for those people also who have special abilities. And as the concept behind the word Divyang was that let's not focus on the disability, focus on the ability. Every person has some or other ability, right? And everybody has some disability. So we should focus on the ability of the person, and we should develop assistive technologies so that that ability is enhanced and the person is able to contribute to the society. And that was the prime motive of keeping that track also in the conference. So with that, with the great effort and support of our own people and others friends, we have reached here today in the inaugural session. I thank all of you to be here, and let's see that in this 2 days conference some good future roadmap is also created. I will request all of you to document all the discussions and publish it in a form of report, so that this report can be also submitted to the government, as it is the year of presidency for India in G20s. So thank you.
Thank you, sir. We'll certainly go by the words of encouragement that you have given us, and certainly this will continue with your blessings and with the guidance of all the esteemed panelists and authors that we have with us. I would now like to call upon our guest of honor, Professor S.N. Singh, Director, Atal Bihari Vajpayee IIIT Hyderabad, IIIT Gwalior. Professor S.N. Singh has obtained his MTech and PhD in electrical engineering from IIT Kanpur in 1989 and 1995. Presently, he is the director of Atal Bihari Vajpayee Indian Institute of Information Technology and Management, Gwalior. Professor Singh became the first Asian to receive the 2013 IEEE Educational Activity Board Meritorious Achievement Award in Continuing Education. He is also recipient of INE Outstanding Teacher Award 2016 and IEEE R10 Region Asia Pacific Outstanding Volunteer Award 2016. Professor Singh has published more than 500 papers. His H index is 57 and citation is more than 12,000. He has also written 30 book chapters, 8 edited books and 2 textbooks are on electric power generation, transmission and distribution. And the second book is in Basic Electrical Engineering, published by Prentice Hall of India. Dr. Singh is fellows of IEEE USA, IET UK, INE, IEI, IET, and various other organizations. Ladies and gentlemen, it is our honor that Professor Singh could find time out of his busy schedule and accepted our request to be the guest of honor. I would now request Professor S.N. Singh to please address the gathering. Thank you, sir.
Good morning to all of you, the people sitting on the dais, Professor K.K. Agarwalji, this eminent personality in this education area. And always I learn from him whenever I have heard his speeches. Many occasions we shared the dais, and always I try to get motivated and also learn many ways. Professor M.M. Tripathi is a young dynamic professor as well as now administrator of the DG NICEDT. You people have witnessed it, and always try to do and think what to do best for the NICEDT or wherever he works. He was in DTU as well, and again he's in DTU, but he's on leave. This Ahia, Pillaji, and other people are sitting on the dais, various directors, various executive directors, NICEDT people, and participants, ladies and gentlemen. You see, this theme of the conference is the digital technologies. Two things are, and also it is a club with the skilling. We say skill. Once it is start, the two parallel systems were running in our country. One is the skill, another is the knowledge. For example, a person is having the knowledge doesn't mean he is having the skill as well. Even though me as an electrical engineer, I know how this fan is running, but if it will be given to me how to wind it, I cannot do. I know the principle. I know the technology. I know the number of turns. I can calculate each and everything. But the skilling is the different and knowledge is different. Now this as the time has come, we have to connect both together. And I'm sure, just I was watching this various expos, this NICEDT is basically having now merging the knowledge and the technology as your skilling together. And that is the need of the hour. That is the need of hour. And always it is the government of India is also focusing. You see this, the phases of changes we had when we become the independence. What happens? At that time our technologies were very old, or it was borrowed by the Britishers, or very in the nascent days. When our independent India was born, then the government decided to go for the industrialization, to have the heavy industries, all the big industries we started at that time. And for that we required the skilled people and the knowledge people. So that's why the various engineering institutions, various IITs, NITs, RECs, various were in the phase-wise they are formed. And we started then all the branches of engineering like civil, mechanical, electrical, they started at that time. No doubt before that also we had the engineering colleges, like Roorkee we had, West Bengal we have, but they were producing some skilled people or overseers, etc. Then it was thought and invented, always we wanted to do the work in the easy way, then electronics was built up, and the mercury arc valves were there in the beginning. Then we started going for the various electronics, maybe power electronics, small electronics, high frequency electronics reform. So the electronics engineering came. Now knowing this electronics, we know that it can do many things. And using this electronics, then the computers were developed, and you can say how it is, and the computer sciences started. After doing this, then this IT or electronics, computer, Then we wanted to think about the digital era. Digital, no doubt, beginning 0 and 1 game was there, and it is never good. It is a good or bad. There is some intermediate states are also. Then the digital is coming to it. So now and after the digital, now we are talking about the data. What will be the next? Because we have the phases of changes. Every 10, 20 years, the technology is changing in the different form. Every time you can see, just you can remember even from the varying era, when we say the Harappa civilization. So the technology is changing, and the people are, those are very successful, always they see the 5 years or 10 years down the line what is going to be the new technologies. And that's why those are big industries, are big successful entrepreneurs or incubators. They think it is going to come in the future. No doubt some people say that it will be electric vehicles. Digital is already there. So I'm talking about what will be there. So based on that, various deliberations, various even the discussions, that's come out, and then technology will be there. One time I heard in one of the speech of Kalamji, he said, you see, there are always the good things comes with the surprises. You see this Galileo's formula, Archimedes' formula, James Watt formula, all this just watching, observational skill was so strong for them, and based on that the theorems were derived. So it is believed that there is a possibility, that's always I say to my students as well, there is a possibility, just like we buy milk every day in our house, we can buy energy every day. Means we can buy an energy socket here, put it in the house, 24-hour energy is supplied. No need to wire, nothing, only the house will be there. If this technology will come, you can see the major change will be there. No wire, no powerhouse, nothing, no environmental issue. We can develop these type of energy storage devices. We can produce these energy sources in our Sahara Desert or Thar Desert, where the solar power can come. So that is one revolution in energy section. Maybe I'm not saying only this. Maybe the future in other data science and other things. No doubt we are talking all the AI, machine learning, blockchain. These are the different technologies. Now people started thinking these technologies are good for society, but also they are very bad for society. Always you see the kids, they keep on playing, keep on doing. They are good for entertainment, but not 24 hours. WhatsApp is very good for the instant messaging, talking, chatting, viewing. Everything is there, but at the same time, how much time it is killing. So now the people are talking, why not we can talk about the trustworthy artificial intelligence. And there is expectation that maybe in the 2030 onwards, right now your AI is doing a lot of things. You see this? Your GT, what's GT and all the things, you can just give the words, it will prepare your PowerPoint. So all the students are using now. So many advantage technologies are coming based on the AI, but they are also giving the different type. Now if you say, just remember the number of your friends, nobody is remembering. If mobile is lost, we are just lost. This is happening. Means we are dependent on the technologies, so dependent. Because even though something, suppose you missed your phone at home and you are coming to the office, you will not work on that day. You will not work, although it is not assisting you to work. But missing something is missing in my life. So we are so attached. So it is believed this AI is going in that faster rate. The future can be that even though there is no emotion in AI, no doubt we say, hello Google, tell me this. Say something yes or no, whatever you can say. But there is no feeling. We can cry, we can laugh, we can have emotion. But the AI-based technology can have this. But it is expected, it is also going to come with the AI in the future. And just what will be done? And people are doing a lot of background R&Ds are happening across the globe. And you know, these are all the copyright people are doing. So many things are there. Coming to this conference, no doubt the conference is a platform where we can connect the people, convey our ideas, and basically convince our ideas. These are the, no doubt with previous 3 years or 2.5 years, it was due to COVID, we were not very much, no doubt WhatsApp and other things were there, online was there. So you see, this COVID has even though given a teaching and learning to us, that now we can go for online. Now all labs are now virtual, classes are MOOCs are there, so many things are online also. But it is always, if you are going for one way, it is not sufficient. We should have the blended. We should have that. This program is also blended. One person is going to talk from Australia. You can see how much money and time is saved with this. But if you can use those technology in the proper way, it is always also better. So the conferences are basically convincing, connecting, and meeting. So that's why I was talking with the Madan, that you can do this is a regular process. Yes, sir, it is planned, and already he announced it is going to be in Guwahati. That's I'm surprised and good. So it is basically, it is giving energy, connecting the people, having the energy, going back to do something. Otherwise, life becomes almost boring, nervous. Kya ho raha hai sab usme? Roz coming office and doing same sort of thing, going back. But meeting people, having something fun, learning, listening, and lot of takeaway that we are going. And always that's technologies, we have all the technologies. In whatever form, that's the technology for the deprived people. Already he's talked, that is very, very important. Technology for humanity. Always I say technology for not deprived humanity. And if that technology is there, it is the best. Humanity technologies are there for to devastate the whole world. So that we are working for that technology. Again, it's highly debatable, highly debatable. We should not go in that. But the technology at the same time we can producing and we can give, that will be the for humanity, and that will be the changing world. It's increasing our lifestyle. It is basically our whole standard is changed from just 10 years before, you can see, and not what we are having, how fast the life is moving. We are doing the parallel tasking and all these things. In the same person, now it is doing two works together. He is listening also, doing something also. Earlier it was not possible. So a lot of things we are doing, and that's I say it is now the technology and the knowledge should club together. And I'm sure this NICEDT has a lot of skill training it was they're doing, and now they are going to form a university that is a knowledge. And if that will come, I'm sure it will be a unique and the best in the world. Thank you very much.
Thank you, sir. It was indeed really wonderful to hear that NICEDT is actually working towards bringing the technology and skilling and knowledge together. And certainly, as you said, that the future is moving faster than we think, and that's the reason why Peter H. Diamandis has written a book titled The Future is Faster Than You Think. Certainly, sir, certainly the words were really great, and we are really thankful to you for delivering such a wonderful speech. Now, as DG sir has said, we have with us our last chairman of our governing council of DOEC, Professor K.K. Agarwal, who is also our chief guest, and it is our honor to have him here, and he is a man of great repute with glorious career to his name. He has been associated with the National Board of Accreditation in various capacities since its inception, and was chairman EAC Tier 3 before taking over as chairman in NBA on 14th of January 2019. He has had a distinguished service era of 27 years at NIT Kurukshetra. He is also, it is also his alma mater in for his MTech and PhD. He is a BE Engineering from Punjabi Engineering College. He is a president of Southeast Asia Regional Computer Federation. He is president of Computer Society of India, and he has been honored as an honorary fellowship by Broadcast Society of India, IET, and Computer Society of India. They have honored Professor K.K. Agarwal with Lifetime Achievement Award. So we would like to hear more from Professor K.K. Agarwal, so I'll cut this thing short and I'll ask Professor K.K. Agarwal to please attend us. Thank you, sir.
My great friend, Professor S.N. Singh, Director of IIITM Gwalior. We have worked on several fora, multiple number of times. Dr. M.M. Tripathi, heading this institution, former professor of DTU. Professor Rajkumar Bhuya, who will join us online in a few minutes. Dr. Yahya Al-Mazruki, Executive Director, who has specially flown for this function. Thank you very much. Then colleagues from NICEDT, Dr. M.M. Pillai, Shri Partha Adhikari, Dr. Jayanta Singh, distinguished delegates, very eminent speakers, audience, authors, ladies and gentlemen. It's a great pleasure to be here this morning, which in some sense I consider it as homecoming, in the sense that, as Dr. Tripathi told, I was Chairman DOIC, erstwhile name of NICEDT, long time back. And after that, I think it's for the first time that a professor has been made Director General. And therefore, I definitely expect academic and research activities to take a boost in NICEDT, in addition to the extraordinarily good work done by DOE, ACC and NICEDT all these years. Friends, today we talk about digital technologies and all that, but imagine the time, at that time when DOE, ACC certification was the only certification in the country which meant something. And many of you may not even remember that time, but the only certification which was valid for ICT technologies was practically DOE, ACC, OA, BC, etc., etc. And I remember the mad race for those certifications and establishing centers and all that. So digital skilling is not new to NICEDT. As a matter of fact, it has been forte of NICEDT to begin with. But now, as Professor Singh said, right time to combine knowledge, technology, skilling all together. So ICT, C stood for many things. I think C stands for convergence also all the time. And this is what we are expecting today. Friends, when I was President of Computer Society of India, in that capacity, we were member of IFIP, which is International Federation of Information Processing. And way back, I think 15 years ago, they had identified 64 digital skills which should be acquired by individuals. So digital skilling is not a new concept, but it has got a new boost. It has got a new impetus. As a matter of fact, thinking life digitally has been a way of life. I've been saying sometimes, when anybody says, what is your age? You say 62 years. You say 45 years. It can never be 45 years exactly. It has to be something, something, something. But we always digitized it and expressed it in words. So expressing analog quantities to digital quantities have been a way of life. In technology, it came a little bit later because analog technologies came up first. As a matter of fact, history, changing history and changing history of science and technology is very difficult. I still fail to understand why should we still continue to teach analog electronics before digital electronics. It should rather be the other way around now. There is no need to go in the same cycle which used to be there earlier. The relevance is different. So friends, when we talk about this conference on digital technologies, I think there could not be a time better than this. As a matter of fact, life cannot be imagined today without digital technologies. And the primary focus for digital technologies came in for our desire for speed. We wanted higher and higher bandwidth, which was not just possible by analog systems alone, and digitization had to come in. I don't think we could have ever thought of 3G, 4G, 5G without digital technologies being on the scene. So this became almost a must, and one had to go ahead and do that. Professor Singh rightly said that technologies, including digital technologies, can be good, can be bad. He mentioned about artificial intelligence, which is giving us great advantages, but is also threatening us a lot in many areas. And I remember a very beautiful article. It says, making better and better robots who can be as close to human beings as possible is a very great idea. But in the process, converting human beings to robots will be a very, very bad fallout. And that happens. We are becoming robotic in society, in life, in education, in this, that. SOPs govern us rather than emotions govern us, feelings govern us. I read a beautiful article which says artificial intelligence is welcome, but if it leads to natural stupidity, is it still welcome? We have to think about it. Because if all the time we have to depend upon the computer to get an answer, then it is something to be thought of. Somebody wrote a small correspondence type of item. He says chatbot is one of the latest of digital technologies. He says he asked the chatbot, please complete the sentence, if I am in utter confusion, what to do? And the chatbot answered, believe your gut feel. So the utmost of digital technology also ultimately tells us that your own gut feel has something very important to be believed in, to be acted upon, to do that. So, my dear friends, we'll have to strike a very great compromise on these two, great balance between these two. And as a matter of fact, this is not true of digital technologies only. This has been true about any technologies. I've been saying, say for example, fire. When fire was invented, it was to cook the food, basically. But if you use the same fire to burn the enemy's house, fire is the same. Knife was invented to give you good tool in the kitchen, but you use the same knife for stabbing, it's your choice. Wheel was given to you for all the transport, but you use that wheel as shastra, it is your choice. So every technology has a plus and minus. I don't think there has been a technology which has been always having all the uses, positive uses. And it is therefore for the society to be more and more conscious of the positivity, of the attitudes, of the behavior, of the ethics, so that powerful technologies could be used in the positive manner. Because powerful technologies have equally bad negative potential, and therefore societal training in ethics, in value system becomes as important as we go on technologies. As a matter of fact, if we grow in technology, it is equally necessary for us to grow in the values, to grow in the emotions, to grow in the feelings, to be able to make use of the technologies in the right sense. I remember I think about 20 years ago in a lecture I said, I am a student of IT and I always believe I is before T. So human being before technology must be there. If we do not give importance to ourselves, give importance only to technologies, then we will become robots. We will not remain human beings. We have to become technology facilitated efficient human beings, but human being element must remain. Technology should facilitate me, technology should make my life easier, which is happening. Then the further boost on this digital technologies came by COVID, which was by chance, I think. Things would have moved even otherwise, but COVID gave it a push, because you couldn't go to the offices, you couldn't go to the schools and colleges, you couldn't visit the universities, you could not hold conferences, you couldn't travel. So digital technologies got a boost by default. And again a plus and minus. Some things are very good in this implementation and some things are pretty bad. I have, from an education field, I know online education has great advantages, but online education has great disadvantages too. As a matter of fact, the whole world is still struggling to overcome the learning deficits which have been caused during the COVID, how to overcome them for the further years. I have seen teachers taking classes from the bedroom and in any dress and whatever, and the student running with the mobile in the kitchen, eating food and attending class, so on and so forth. So that has been bad part of it, which has to be taken care of. Friends, skilling and digital skilling using digital technologies and combining skills and knowledge. As a matter of fact, some conferences and some academia have started emphasizing very strongly in favor of skill vis-a-vis knowledge, which disturbs me. Skilling is very necessary, but skilling at the cost of knowledge will probably do us damage again. Skilling has to be in addition to the knowledge, along with the knowledge, because knowledge is changing very fast, but skills will change still faster. Two more points which I would like to say for 2 minutes before I close. First is, quality has to be a very, very deterministic factors when you use digital technologies and digital skilling. See, when we used to talk about analog systems, 5 will become 5.1 and there will be an error of 2%. In digital, the only error is 0 becoming 1 or 1 becoming 0. And that error is always fatal. And therefore, we have been talking right from beginning of digital technologies. I myself had worked on that area. Fault-tolerant computers. Fail-safe systems. And see the terminology, fail-safe systems. Even if you want to fail, system has to fail, let it fail safely. Fault-tolerant computers, self-repairing computers. These are the kinds of things which were invented because we were always conscious that the failure is inevitable, it can happen, it can be very dangerous, it can be very disastrous. Therefore, we have to make sure how to handle it. Because in digital technologies, if 1 could mean turn to the right, 0 could mean turn to the left. And if 1 becomes 0, what will happen, we don't know. So therefore, self-correction things had to be come in. Therefore, I definitely propagate that the quality has to be built in when you go to digital technologies, digital skilling. And maybe because I was Chairman National Board of Accreditation for last 4 years, quality has gone more into blood, although I had worked as a researcher also in the area of quality. Finally, friends, I also believe that digital technologies have some multidisciplinarity built into them, which we forgotten consciously or subconsciously, I don't know. I have been always saying computer science is probably one of the most interdisciplinary subject, although today in engineering colleges, unfortunately, that has remained the only subject. Mechanical has wiped out, electrical has wiped out to computer science. Why I say computer science is the multidisciplinary subject? Because can you imagine philosophy and mathematics coming together? That is computer science. Giving mathematical language to the philosophical logic is the birth of computer science. That is what Boolean algebra is, that how to give mathematical language to the philosophy. And even today, very few people can understand a subject like philosophy can work together with a subject like mathematics. But that's the birth of computer science. And finally, friends, Shannon, if some of you have worked in that area, have heard of the name, is the one individual responsible for digital technologies. And I would end by saying, many of you may not know that he had a degree in mathematics and a degree in electrical engineering. And that is why Shannon could do what he did. And that is what we are promoting to learn today, multidisciplinarity in education. So we have a lot to learn from these things. I'm so happy that Professor Tripathi is giving very strong attention to education. It will become a university. I think there's a delay for about more than a decade on the part of the government, so sooner we do it, better it is. I remember probably FILE had started on this as a university more than a decade ago. But let's come see that it comes to fruition. He is also attending to it in the research concept, making it a good research center, and so many centers of NILT are doing well. I wish this conference all the great deliberations and give us strong food for thought to Professor Tripathi and his team to carry it forward to the fruition of a university and a good research center. Thank you very much for giving me an opportunity. Thank you.
Thank you, sir. Had time permitted us, we would have, we'd really love to hear you for a more longer time. And we are certainly committed to carry on the legacy that you have instilled as part of DOACC. And yes, it's true that technology gives us power, and with power comes responsibility. So we need to throw caution to the wind to use that technology with greater responsibility. And now it is a matter of pride, as Professor S.N. Singh a few minutes back told us that knowledge education is now entering into from an offline mode into a blended mode. So now we are going to enter into a blended mode of conference where Professor Rajkumar Bhuiya, the superstar of researcher, that is one of the award that was given to Professor Rajkumar Bhuiya, who is going to join us from Melbourne. He will be joining us from Melbourne, and he's a Redmond Barry Distinguished Professor and Director of Cloud Computing and Distributed System Clouds Laboratory at University of Melbourne. He is also serving as the founding CEO of Manjrasoft, a spin-off company of the university, commercializing its innovation in cloud technology. He has authored more than 850 publications and 7 textbooks, and he is one of the highly cited authors in computer science of software engineering worldwide. His H index is 158, G index is 342, and believe me, he has citations of more than 132,100 plus. So ladies and gentlemen, he is also recognized as Web of Science highly cited researcher for 6 consecutive years since 2016, IEEE Fellow, Scopus Researcher of the Year 2017 with Excellence in Innovative Research Award by Elsevier. He has been recognized as the best of the world twice for research fields in computing systems in 2019 and software systems in 2021, as well as a lifetime achiever and superstar of researcher, as I started off with, in engineering and computer science discipline twice, 2019 and 2021. So without any delay, we would like to go online and hear from Professor Rajkumar Bhuiya. Professor Rajkumar Bhuiya, over to you, sir.
So thank you very much, sir. So you can see my slides. Hello, you can hear me?
Yes, sir, we can hear you.
Oh, thank you very much.
We can hear you, sir.
So, thank you very much. Thank you very much for inviting me to be part of this very interesting conference. I like to thank our colleagues, starting with Professor Tripathi, Director General, who invited me to join this conference. Of course, this was also triggered by Dr. Jain Singh. So far, my colleagues have already alluded about the importance of skills, the technology, knowledge when you bring together, and what you can accomplish in terms of impact on the humanity, bringing numerous benefits to everyone. And of course, at the same time, the challenges or the dark sides of this advanced technologies, including mobility, computing everywhere. What happens if we miss it? What happens if you lose it? So this is what Professor S.N. Singh already mentioned. So of course, I had a couple of years ago, I had an opportunity to visit Gorakhpur. So thanks to our Professor S.N. Singh when he was the VC over there, and I'm very nice to see, learn that he's now directing IIIT Gwalior. So let me just highlight some of the latest technologies in this area, which we call cloud, edge, and quantum computing. and our colleagues have mentioned about AI. And obviously these AI applications, you need a necessary digital computing infrastructure to support the AI application, to enable them to do those interesting things. So this is where this computing system technologies come into picture. So, so let us go a bit deeper into those aspects. And when we look into some of the hot technology trends, so certainly skills is a very important one. Then the application of technology to real world problems. Even if you think of AI, so not just the core AI principles, but how can we apply this AI to the real world problems is one of the very prominent area to look into. Then the topics that I am going to discuss today are like cloud computing, edge computing for Internet of Things applications. Then there is another one that is coming up very rapidly, what we call quantum computing. So this digital technology transformation from this what we call binary computers, like a computing with the representation of 0, 1 towards multiple bits, what we call qubits, and opening up huge opportunity for the future applications. So here I was told that I can speak for 30 minutes. So I have prepared a couple of slides so that we can focus, then show you some pictures of those architecture. So let me briefly present the computing paradigm that we have seen so far. So then look at how cloud supporting application. Then we take a look at a cloud architecture, keeping in mind of this emerging applications in AI, and illustrate that with the technology and also some of the application case studies. So then we take a look at briefly about this what we call Internet of Things. So everything becoming part of Internet. That is what we call digital transformation. So this digital transformation to support them also interesting new computing paradigms have come. So I will discuss that paradigm along with the applications of those. Then very briefly I'll touch on quantum computing. So quantum computing is a big area, but I will touch on how quantum services can be made available through this cloud computing to support application, and that is how today the world is moving towards. So as you all know, there are different computing paradigms have been popular, and our colleagues have already talked about some of the historical advances. And moving rapidly towards during last 10 years, we see what we call this cloud computing, making computing as a utility. So instead of having all the infrastructure built yourself with your own organization, you can rent that capability and have applications available some remote places, remote servers, and they can serve those applications from remote places. So this way computing become utility. Just like water as a utility, electricity as a utility, network as a utility, especially communication network. Similarly, computing also become a utility. So this is what cloud computing has actually achieved. And during the last 10 years, we saw many advances, and today it has become ubiquitous. On the other hand, we see now Internet of Things is rapidly moving, where concept of networks of computers to network of everything. So which means the data capture will be huge from various not just computing but also physical infrastructure, and that need to be analyzed in real time for rapid action. So this is where notion of edge computing came into picture. And in between we now have got this quantum that rapidly emerging, so we will discuss that also very briefly. Then what is the trigger for all these advances? As our colleagues have mentioned, applications. So applications in the past were primarily big scientific, big data, or what we call big science, and military applications were the big driver for advances. Even in India, developing Indian supercomputers, the big driver at that time was weather forecasting or sometimes maybe military application. But now advances are more and more driven by big population, and especially when you have problem like this COVID-19 pandemic. So how do you bring the services to this big population, even though they may be working from home or living at home, not interacting so much physically. So that all brings up more and more advances in a unique way to the technology. So here is a brief view of what cloud computing looks like. So we have various computing capability like storage systems, compute systems, and applications somewhere in the network. A third party, what we call cloud service product, they have set up this service for you. You as a consumer simply subscribe to those services, use it, and pay for what you consume. That's the model. You may have subscribed to one service provider. That doesn't mean that the service provider does everything for you. They may be using capability from other multiple providers that are distributed geographically, and then they combine together and deliver to you. Say for example, if you have India cloud service, so you might have a cloud data center in Delhi, you might have other in Bangalore, other in say in Guwahati. You can bring them uniquely together then to deliver ultimate service as a combination. So this is how most of these computing services are created. And there are many applications already which we are using day to day, and you're using today for this conference too. So the business applications, traditionally if you set up in your own organization, very expensive to build infrastructure, and applications themselves very expensive. But today you can, thanks to cloud computing, so you can rent services such as customer resource management, enterprise resource planning. So that means the startup, what we call the ecosystem, can be quickly put together and support them. So this is one big success. Other one is this consumer application, that common man that they're using. So for example, this Twitter is running on a cloud, then the Dropbox, which is a cloud storage running on a cloud, and more importantly, the video conferencing software systems such as Zoom, and today we are using WebEx. So these are actually cloud-based video conferencing software system. You can see we just have a client, and then we are connected so quickly, and we are getting the best response time. This is thanks to multi-cloud architecture on which these applications are running, and then of course the big trigger. Then like this, there are many applications are there in social networks such as Facebook and Gmail. So these are actually running on a cloud environment. So this is a big success of cloud computing actually already. Then meanwhile, we continue to see new digital technologies introduced. And one right now is most prominent is what we call containers and microservices. Earlier, cloud systems were virtualized and offering services, but now they are moving towards what we call containers and microservices. And this has got big implications on software engineering. As you all know, even our colleagues have mentioned about, previously this DOE, their efforts in this computing certification and all. So at that time, the software engineering was primarily monolithic, then shifted towards service-oriented. But today it is moving towards third generation software engineering, which is microservice-based software engineering. So this is another important skill that we need to inculcate. I hope that this new university, many of our colleagues have mentioned about this NICEDT moving towards model. I think the software principle they are going to push are going to be more of a microservice-based software engineering. Very important to make sure that. Then of course we have many other advances such as blockchain, which is generally associated with the digital currency. But the same blockchain can also be used for creating trustable services. And especially various like land record management services, these requires blockchain integration. So I'm sure this presents a huge opportunity for India to legitimize how the land records and how the is managed in cities and in other places. Then moving towards this what is called COVID-19 is also another big trigger. As our colleague mentioned, because of it, a lot of digitization is accelerated. And in fact, advances in cloud computing has happened a lot to support this work from home concept as well, whether it's a medical concept or a medical application or any other domain. Even the use of cloud computing during last 2 years almost doubled or tripled thanks to this COVID-19. So as application move towards cloud concept. So now this cloud concept, we talk about so many applications. All kinds of applications delivered as service through cloud. So how should the cloud architecture be? And how should the future cloud architecture has to be? Just at a glance, so this is a more deeper aspect of cloud computing. Essentially at the bottom, you have many data centers that are physically distributed, like across multiple cities or multiple countries around the world. And these servers are interconnected, and then they are virtualized through what we call software-defined networks. And then the compute virtualized through a virtual machine. Now you go towards application or users. So when users make a request to cloud environment, so they have expectation of the quality, certain quality expectation. So such requirements coming to a cloud system, and the system should look into, can I honor this request? If yes, the request comes in, then you have got what we call virtual machine is created. So there is no server named after you. So in cloud environment, what is given is a virtual machine. So the virtual machine that is created and mapped to a suitable server, and then from which application is running and supporting users. When number of users are increasing with time, say if you initially got say 50 users, then become 500 users. When number of users increase in cloud environment, dynamically the resources are provisioned. So you don't have to have fixed set. So based on the demand, the resources are dynamically provisioned. Then of course, and this provisioning can happen in one location or across multiple locations. Today we are using this WebEx conferencing system. We have participants from across India possibly, and I'm joining from remotely. So so the users are coming from different places, and to provide them good support, the system, when we initiate a conference call, so initially most of them request me map to a Delhi data center, cloud data center. Then later on when I joined, it moved one more request and created in perhaps in a data center located here in Sydney or Melbourne. So this way we can have a better interactive and support. And when the demand decreases, so then dynamically it reduces. So this is called elasticity. So we can dynamically expand and shrink as necessary. With this model, we can make the application highly scalable, and we can also make services that are provisioned and delivered as per the quality of service requirement. So thus we can achieve energy efficiency and also fault tolerant. So if there's something fails, though you can easily migrate those services to other places. This way we can always provide uninterrupted services to end users. So even this our colleague mentioned about WhatsApp, for example. So this WhatsApp is an application running on a cloud. So you can see these all are we expect those services available all the time. So such requires such an ability, and this way we can also provide cost efficient resource services. So you don't have to rent when you don't need them. You rent what you need and how long you need, and then start delivering those services. So that is how the cloud services are created. Now when you come to application, how do you build application? We also need to build our application that can easily expand or shrink based on the resources that we allocated. So in that context, let me briefly present one of our own software technology called Aneka. So this is a cloud application platform for creating such elastic applications. So within this Aneka, we have very unique features. So to program application, so you can create application using what is called a thread model programming, task model programming, map reduce model programming. All these models of programming are part of Aneka's first component called Software Development Kit SDK. And once you build them, you can deploy either on a cloud located in your own organization or public cloud in a seamless manner. So this is a very unique technology. When I go deep inside this Aneka architecture, it is actually service-oriented architecture, and each of the services are hosted within Aneka container. And using those foundation services, you can create different models of programming: thread, task, map reduce. So this is what we call world-first platform supporting multiple model programming in a single container. And tomorrow, let's say you come out with a new idea for a new way of programming application. So that simplifies, say, quantum computing application programming. So you can easily build that within Aneka and then map it to suitable, hardware. So this technology actually, we patented the model of this multi-programming model hosting environment in India, in US, in Australia. So this recently, this is also the patent is, certain rights are acquired by various companies, IT companies that you can think of, including IBM, Microsoft, Oracle, and various others, because this is a very unique, innovative way of creating software systems. So this is as a result, so many companies have acquired this IP for their use. So how do we actually program? If I go a little deeper, so if you've got multiple servers put together, so then let's say I want to create an application for, say for example, in this conference hall, I'm sure there are cameras, and so the cameras are capturing this data, and I want to analyze the data real time to find out who all are attending this conference, or what is the status, what is their mood like. So based on that, let us say I change my the speech or my discussion. So this is a combination of the camera's data, maybe some AI application that gives me feedback on the mood of participants, how they're feeling. So accordingly I can change. So such application requires us to scale and do it in real time. So not just on single server, you do across multiple servers. So it requires to real time requires multiple servers. Unlike single server might take 5 minutes to give me a decision, but I want real time. So in this case, I can have task. For example, here's a simple task, and I want to run this task. The various camera images that are coming, video coming, I process them in real time. That requires me to do in concurrent processing. So this is where I can simply say the task, that processing, then concurrent operation. So that's all I need to do. Then the system Aneka will automatically take care of executing those operations across multiple servers in seamless manner. You can see as a programmer, as a developer or a software engineer, you don't have to think too much about where do I run, how many resources are required. So you don't need to worry about. You can simply program your AI task and the rest of it done by this Aneka. So since I mentioned AI, I will soon discuss about such applications. So this technology is used by many users around the world. So just to highlight, let's say in China, China Railways Corporation using it for designing high-speed trains. So in India, ISRO, and then in Washington State University in USA, using it for medical data analytics. When you have medical data analytics, you have various data concerns, privacy concerns. When the patient data is captured, so you want to make sure that the privacy is maintained. So in which case maybe some private, when you have medical records, some records are sensitive, some are non-sensitive. So this university people have used this Aneka and developed a deep learning method to classify medical records into sensitive and non-sensitive. Sensitive records are processed on a hospital cloud at Washington. The remaining ones are processed on a public cloud like Amazon. So this way you can support such privacy-aware medical data application. So like this, there are many applications are done. So let me just briefly share 2 or 3 as a case study to impress you on the application. So this is from China Railways Corporation. So these are different design scenarios. So they used to do this rendering using Maya software on this 4-core server. So this was taking time anywhere between 24 hours to 80 hours, like 1 day to 4 days. So in order to reduce the time to discovery, they have set up a private cloud using our Aneka software, and we have a tool called Design Explorer. Using Design Explorer, they are able to compose this application as SPMD, single program multiple data application model, and run it on this private cloud. And using this, as a result, what took 80 hours, the same thing they were able to do it in 2 hours. Sometimes you have an emergency, so you want answer in maybe 10 minutes. So within Aneka, so we have features where you can easily specify, something like a deadline. So you can say this deadline equal to 10 minutes. You can set deadline in real time, 10 minutes. Then of course you are going to use multiple cloud from not only your local resource takes you 2 hours, but you want answer in 10 minutes. So we may have to dynamically rent resource from other centers, like for example from Hyderabad, Delhi. Then we may want to so for that we also need to set budget limit. So there is a deadline, and so budget can be here you can say budget is equal to something like 200 rupees. 200 rupees. So you can set in real data. So now this system on your behalf looks into marketplace, looks into how much extra resource necessary and what is the price of those services available externally, and select those that are affordable to your use, and then use them and deliver answers by that deadline of 10 minutes. So this is like how we operate in a real life, and the same thing we can do in the computing technology. So this is what the new digital technology is. So that was China. Coming to India. So ISRO, of course, as you all know, that they launch satellites regularly for different purposes, including desire to go to Moon or Mars. So such satellites capture the data, and data comes to receiving station. And then what do you do with those data? So massive amount of data captured continuously per second. So that data is stored in the local storage. So such data need to be analyzed to, for example, maybe disaster management application. So one such application was created in Hyderabad Center of ISRO for disaster management purpose. So that uses our Aneka technology to do in real time. Sometimes they may have to use multiple data centers of this ISRO, because as you know, ISRO has centers in Delhi, in Ahmedabad, in Trivandrum, in Bangalore, in Hyderabad. So sometimes your local resource is unable to meet your needs. So at that time you can lease from your other centers. So if it is a big privacy concern or strategic application. So this is a technology that in ISRO in India is used. So those are more of a big application. Let's come to simpler applications that common man benefits, especially AI application. In AI, as you all know, so there are multiple types of techniques. 2 are machine learning and then deep learning. So deep learning applications are very much used in object detection or various other cases. So one such is like, for example, videos and images processing. So here, for example, we have cameras deployed everywhere. So on patrolling cities or transport systems or even roads or highways, wherever you see these cameras everywhere. Even in the temple, you go to any temple, most places there will be multiple cameras watching. So what for? So there are videos and camera images are captured, and you need to analyze those to identify real time object of interest. It may be security application or some enforcing some rules and regulation. When such an application data is analyzed on a single machine, it might take an hour. But you want answer real time. This is where cloud will help. So using this Aneka, IIT Delhi researchers have taken Aneka and then took this data, and there is an application called deep.py. This is a Python based deep learning program. So they're able to convert that into a SPMD application using Aneka task model programming, and able to run those within Delhi, IIT Delhi resources, and also this Microsoft and Amazon resources in seamless manner. And here you can see, so this is the input image. So this input image fed it to the system. Then it is able to detect objects. What are the objects are there in the student lab? For example, how many chairs are there? How many monitors are there? How many mouse are there? How many keyboards are there? How many people are there? Is there something missing? So like this you can do very interesting application. So this is an example of object detection in a cloud enabled by Aneka. Coming to COVID, we all know that during last 2.5 years, there is a huge effort in conducting research. Everyone started doing the research in the context of COVID, whether they are medical people or economic people or science people, somehow directing their effort. So as a result, during last 2.5 years, more than, actually this is we looked at 128,000 research papers, but by this time, right now, more than 500,000 research papers are published. And if you are someone want to find out what is the effective social distancing, what is the best vaccine for the new variant of COVID, so if you want to go through all the research publications, it takes a lot of time. So we want to do it in quickly. So this is where there is a data set available called Code 19. This is the COVID Open Research Dataset Challenge. This data you can take for 500,000 research papers, their abstract and various things. Then so here we created a machine learning program. So this is the ML machine learning program, and using Aneka software. So these machine learning tasks were actually processed in parallel, concurrently, and to deliver results in real time and early. So for example, here you see number of research papers. So suppose you got 50,000 research papers, you want to analyze them to find out which is the best vaccine for this variant, or what is the best social distancing, for example. So when we looked at, when we processed on a single node, what took 20 minutes, so when we provision something like 4 servers, it just did it in 5 minutes. If you provision even more servers, it might do in 2 minutes, correct? Or you increase number of research data from 50,000 to 500,000. Then obviously you may have to provision another 200 servers to get it in real time. So this is an illustration of applying this technology even in the context of COVID or security. So this Aneka technology, is available from manjarasub.com. So this is a startup company. We actually started almost 10 years ago. So a lot of advances happened. So right now we have got Aneka, 5th generation technology. So this technology is used by many people, which are highlighted, but also in education. So today this conference, I see many colleagues who are from education community. So numerous universities across India, are teaching cloud computing, courses in the form of theory, and many of them have set up, cloud-based laboratory to provide a hands-on experience, all the way from, something like Kanyakumari. So this is where the Kanyakumari is, and towards Kashmir, like IIT Kashmir, and then of course people from Maharashtra to Meghalaya, of course even the Gorakhpur as well. So various people have set up these Aneka based labs in NITs, in various universities to teach this application programming skills. And this is what these are important skills, as you know, for creating a application. So that is about cloud and Aneka application. Let me briefly present this IoT and its application and conclude. So IoT, as you all know, moving concept from networks of computer, the internet, towards networks of everything. So that means everything. What are those everything? Even the trees being part of internet with sensors. The soil, moisture monitoring sensor can be there in the soil, and if such things are used, can be used for smart agriculture, where the water resource can be efficiently used. So not waste water unnecessarily when it's not necessary. So this is where it requires us to integration with the physical world, like if you've got a sugar cane field, so you can have a few moisture sensor that can monitor. Then it can integrate it with say weather forecasting system that can tell you what is the weather like. If it is going to be heavy rain in 2 days time, then there is no need of irrigate that sugarcane field, because to irrigate you have to you have to suck the water from, say, Ganga river or Yamuna river. So why unnecessarily waste the water? Water is such a precious resource. So therefore, how do we use water resources efficiently? By integrating using digital technologies along with the AI, IoT and the cloud. So like this, there are many applications. We talk about IoT based smart world, means using resources efficiently. That's what smart things are, like a smart home, smart healthcare, driverless car. The future driverless car will be very much enabled by this integration of IoT, IoT and cloud platform. So for this purpose, what is the computing model? The first generation model of IoT application was cloud centric. So you deploy your application in a cloud and support them. But as we see, by in few years time, billions of such sensors will be deployed across everywhere. So if you do that, you can't push the data to cloud. So if you do that, the network get clogged, the service quality will be low, real-time application can't be supported. For that purpose, there is a new trend is to use how can we harness resources at the edge of the network. Not only edge of the network, but also the core network and also along with the cloud. So like this, using multiple resources, this is what we call edge and fog computing. So this in that direction also we develop software system, which is a lightweight framework embedded with the blockchain. And this is surprising. So when we say blockchain, generally we think of digital currency, but the blockchain can also be used for creating trustable services. For example, when you collect the healthcare data and the data goes across multiple networks in the edge and the cloud, when the results come back, you want to make sure that the result is trustable. When can you trust? If nobody has tampered your data or tampered the result. So using blockchain, our framework embedded in the blockchain, we are able to provide that kind of support. And we created many interesting applications. One is this healthkeeper app. So this is a device like this oximeter, for which can be used for monitoring various our vital statistics, available for a small price like 500 rupees. That device, you can collect the data, and using this healthkeeper app running on a mobile phone, you can send it to the either edge network or the cloud network. And we were able to do it for various applications, including sleep apnea and so on. And we have demonstrated this also publicly. So here is this device connected to finger, very easy to connect. And then this healthcare device, this is called Internet of Medical Things. And from this device, we take the data and send it to our, the Fogbus system. The system is able to use this Raspberry Pi edge devices or the remote. And as you know, the Raspberry Pi device is something like a small matchbox. Maybe for 300, 400 rupees, you can get a small computer. And this can be hanged at various places. It can be, put it in home or near the camera, and there you can process real time. Sometime you can integrate with the college data center network, or you can use a public cloud. So like this, we were able to integrate and support many interesting applications. And so our colleagues were talking about drone. Drone also we did. So I actually hid on that drone one. So maybe I will skip that. So you can actually, okay, now that I press this, okay. So drone. So drone is a flying robot, correct, as you know. So the drones can also be used in COVID-19 situation. So this was an interesting opportunity, presented for us. So in places like Delhi or Noida, during lockdown, lots of people in the multi-story buildings. Multi-story, like 20-story, 30-story big buildings. And so when people are there, so what we have explored is like these drones. These drones we fitted with thermal camera. We're able to go around these multi-story buildings. We ask people to come to balcony. Then this system is able to identify if anybody has a symptom or a, say for example, body temperature, which can be classified as a, say maybe potential COVID positive candidate. So such a data capturing through this thermal camera fitted with the drone, able to go around, and data brought to the edge network or also some of them into cloud network and process, and then this is able to integrate. So this is one of the work we did during that very prominent COVID time in 2021. So this is, you can see the integration of various technologies with AI, with cloud, so can create outstanding opportunity. Coming to this quantum is here everywhere. I'm not going to discuss too much about quantum, but what I want to highlight is, so quantum, so moving from digital computing to quantum computing. In digital computing, as you all know, when you represent a bit, you use only 0 and 1. That is binary computing. So with quantum, you can have n number of bits to represent one state. So if you have got a state with say 1000 bits, they're called quantum bits, you can compute faster. What takes 1 day, you can do it in 1 second, for example. So if you have such an ability, maybe it can create a very interesting scenario. But programming quantum computing is very hard. So today quantum programming is like what we call quantum circuit programming. This seems like very basic level. So just like some of you know, earlier when we were doing programming microprocessor or creating a digital application, we used to put together AND gate, OR gate, NOR gate, various kinds of gates to create a multiplier, divider, and so on. Similarly, if you want to create application for quantum, so we have got all these quantum bits, qubits, let's say 10 qubits. So this is a program for random number generation. So all these data are coming. You can put different quantum gate operators, then create and then produce a result. So programming like this is very low level. And if you want to program high level, so different companies are providing different programming environment, but it is very low level. You need to understand quantum concept, very detailed. So this means this programming can be very difficult. So we want to make programming easier. If you want to bring this quantum programming, quantum application programming skills to the India, then that low level requires a super engineer to program. But we want everyone to program. So we need to have simplified approach. For that purpose, we created this what we call QFAS, Quantum Function as a Service. So as you all know, quantum systems services today are available through cloud. So cloud has got computer servers. Servers have got GPU, CPU. Similarly, you can also have a quantum processor. So when you have such a thing, so they are available. So we create this QFAS as a serverless function and service environment wherein you can compose your application at high level, and your application can have a combination of quantum code and also the standard existing code, maybe written in C language, C++, hybrid application, the digital computing code. So when such application comes in, our QFAS system is able to identify is this function a quantum function or a classical compute function. If it is a quantum function, run it on a quantum computer, otherwise run it on a classic computer. And here also you got multiple companies like IBM, Microsoft, few others are already providing such capability. So you can actually distribute your computation across multiple data centers, identify suitable quantum necessary for your application. So this is just in brief. So this way we can reduce the complexity of quantum software engineering. So by doing this, we can enhance the productivity of software engineer. Productivity of software engineer means we can build new application for quantum quickly with less investment in time and effort. So that is just in brief. So these are software that I talked about. They are all available for you to download from our website, including Aneka as a evaluation version. With that, let me conclude. So you can see this concept of computing as utility. The concept has been around. And today we have this cloud computing. Thanks to cloud computing, it has become reality. So, and many exciting business consumer applications are on cloud. And today, right now, many of you who are there in the conference, if you are accessing, say WhatsApp or any other application from a remote place, they are running in a cloud. So that is a success. Then in terms of application programming, so this approach of multi-application programming is very unique that we created incorporated into our Aneka product. And also, as I said, so this is now licensed by so many IT companies. So you will see such features in other IT applications also. So this is one of the impacting your research for the global level. So then I mentioned about how this Aneka helps you to rabbit application engineering. Then in a cost efficient manner you can deploy. So we saw a few applications from engineering healthcare illustrating how this technology helps. There are many more applications. In interest of time I just talked about just 2-3. Then IoT is a big thing nowadays, and this Internet of Things, the first generation was cloud centric and the next generation is more of this combination of edge and cloud. So this way we can support real-time IoT application. And coming to quantum is rapidly emerging. I am sure this the new institute that you are setting up, so that the need for also having some quantum subjects, not only on the foundation technology but also on the application programming. So perhaps to start in a simple way. So this is another area to look into. So if you want to learn more about cloud computing, so here is a book. So this is a book published in McGraw-Hill. This is published by Morgan Elsewhere in American market. It might be costing around $100, too costly. So don't worry, we have a solution for India. So this is published in the same book published in India. So this is available almost for $8. Okay, equivalent, something like 400, 500 rupees, depending upon where you buy. And then we also have a same book for even for Chinese also, in Chinese language. So this is available for just $3 equivalent. So this way we need to make sure that the digital services are affordable. So this is another aspect you need to keep in mind. So when the digital solutions are created, what should be the charge to the consumer? So we need to charge them such a way that they can afford. That means if it is in India, if you provide some healthcare service as a digital service, through some IoT sensor, they can monitor themselves how they are doing. Then take care. That way we can avoid people coming to the hospital. So such application services, the people in say Delhi versus people in some villages, in UP. So what should be the price? If you are charging 20 rupees per request for Delhi citizens, then you should charge maybe 1 rupees or 5 paisa to the citizens of UP villages. So that is the affordability is also important. This is another aspect we need to keep in mind. So with that, let me stop here. So I'd like to thank all of you for hearing patiently. So here are my contacts. You can always ask question today. If you want to ask later, you can email me. So this is the University of Melbourne email ID. So that is for those who want to pursue Saraswati. You want to go for higher education, you want to conduct research, you can contact me at University of Melbourne. Or you want to pursue Lakshmi. Maybe you had enough of education, you want to do something, transformative solutions for the market. So you can contact me using my, this Mandrasap email ID, raj@mandrasap.com. So thank you very much. So I'll be happy to take any question that you got.
Thank you, sir. It was really wonderful to know the various initiatives that you are taking and the kind of research is being done in the various upcoming fields and disruptive technologies that is so very talk of the day today. So now we move forward with our program, and in fact in this this G20 presidency year, it couldn't have been a more better time to acknowledge the growing prowess of India as a skilling power, and to honor that, to recognize that, Dr. Yahya Mohammad Sharif Al-Marzuki from Tawazun Council, he is the Executive Director Advisor of Tawazun Council, Abu Dhabi, UAE. He has flown all the way, and yesterday he was hassled because of some visa issues, but still landing today, arriving at 3 o'clock in the morning with very little sleep. He is here, joined us here to give his plenary speech, and he has been, he is the chairman of the Engineering Innovation Solution Center, board member of UAE University College Business and Economy, chairman of Hamdam bin Mohammed Smart University School of Business and Economy, and he has been on various boards where he is doing exemplary work to inculcate the skills, the growing need of skills in digital technology. So I would request Dr. Yahya Al-Marzuki to please come and address the gathering, please. Thank you, sir.
Thank you very much. Thank you for your kind introduction. I came across, when I was doing my post-degree, a gentleman from India, and that goes back to 13 years ago. Please don't go and estimate my age, yes. Oh. And well, when we finish our final, I got 86 with the other group. We were celebrating, and I saw this Indian chap, a good friend of mine. He was not happy. So I went there and said, what's wrong? He said, I'm just waiting for a professor to go to his office to see why I got 98. And here we are celebrating. And I come into this venue today, and there is a different vibes. And I passed by the booth, and the conversation was not about the technical and how do they made the motherboard, but it was more so, how can my technology benefit the mankind? With that kind of thinking, with that kind of grit, with that kind of determination, India is set to lead the world in digital economy. Allow me today, when I was asked to come and talk to, and I would like to call this one the NICEDT Festival of Thinker. It's more than a conference. And as I was thinking when I was asked to come and speak to this distinguished audience, I was thinking what would be relevant? I mean, what should I be talking? So when I Google, and I see all the authors are of Indian, even Harvard, Stanford coming from India. So it was not easy to pick a topic. We have embarked on a digital economy away from the oil and gas. About a decade and a half ago, our government has put in place a strategy to do away from the oil and gas and get into the digital transformation, digital economy. There are various terminology that we can use. Having said that, we had to, like any other nations, look at how this partnership between the academia, industry, and government is shaping. What is our risk appetite? Because in digital technology, your risk appetite, calculated risk appetite, has to be high. Most of the company we found in the country, and for that matter in the region, they are set up for the big boys. And the technology is coming from agile, nimble, small startup companies. And they were not getting even the RFP. They were not getting even the proposal. And those were, I'm not, even on security, when we look at it, it's not the conventional armament or conventional way of securing the human prosperity. It's about the back garage. Technology is a two-way sword. It has a, it depends on the hand of friends or foe. So how do we create a culture? And I saw the word, how do we establish a new paradigm? And so allow me today to share with you what we are doing with regard to digital economy. We have appointed a minister of digital economy, and we also established MBZU AI, Mohammed bin Zayed University of Artificial Intelligence, and to a great degree we have been successful in attracting talent to the country. Are we all set? No. There's other challenges. And this is, I call it, work in progress. With that, it is an honor to be here in Delhi in this event. I join you today, like my predecessor and the moderator spoke. I came a bit late. I missed my initial flight because I didn't have visa, thinking that, we don't need visa coming here. But the ambassador was kind enough to finish it. He said it's the fastest visa I have ever issued to anyone. So in a half hour, I was back in the airport, and I'm so honored to be here. I come from the UAE, United Arab Emirates, where we have been dedicated to building a robust, resilient digital economy. As the subject of digitization of a great interest to me and my nation, I am pleased to speak to you today about some of our experiences as we have sought to capitalize on accelerating transition to digital economy. Specifically, I want to focus my comment first on the value of digital technology ecosystem, and then on what we have learned about the importance of public-private partnership in the managing this ecosystem. While the seed of increased digitalization across all aspects of our lives preceded the start of 2020, the pandemic accelerated and amplified this trend, specifically in commerce. Indeed, e-commerce sales grew to $5 trillion in 2021 and is expected to grow to nearly 7.5 trillion. That is a 50% growth by 2025. The UAE has sought to move fast, not just to be part of this transformation in economic activity, but to be among the leaders. Digital technology currently contributes 9.7% of our GDP, which compares reasonably well with others who contribute around 13% for the world leaders such as Singapore and the United States. Moreover, independent assessment of our digital competitiveness places us 13th in the world, and a clear strength in technology development and deployment, cybersecurity, regulation, wireless broadband use, and public-private partnership. In 2021, the government released the UAE Digital Economy Strategy. This document provides a three-phase pathway to becoming the best digital economy in the world by 2071. One of our short-term milestones is to ensure that 80% of the total economic transactions are digital by 2030. One of our key priorities is to work with the stakeholder to not only improve commercial efficiency through digitization of operation, but also to encourage the establishment of digital technology ecosystem, which we believe will serve as a growth engine for digital economy. It is probably useful for me to say what I mean by that term. I see a digital technology ecosystem as a unified environment in which platform, services, and emerging technology work together to allow companies to become more efficient, profitable as they connect better to consumer needs. This ecosystem requires participation across the supply chain of product and services, the advancement of adaptation of core technology like AI and data analytics, as well as abundance of customer data. For customer, convenience matters the most. Consider how Amazon, one of the most successful leaders of digital ecosystem, has changed many of our lives by providing almost all products imaginable at our fingertips. Or how banks have partnered with payment services and developed applications to make transient and banking much easier. For companies, they can become more efficient and, even more importantly, increase their reach across the border through the digital marketing and digital offering. Effective ecosystems also frequently lead to reduced costs and better, more personalized offering, especially as companies collect more customer data that can be fed back into new product development that subsequently drives more sales and revenue, a truly virtuous cycle. Digital technology ecosystems are providing value today and are expected to do so in the future. According to McKinsey, across at least a dozen sectors, including B2B services, mobility, health, companies are reinventing themselves as vast ecosystem network of network that could add up to 60 trillion integrated network economy by 2025. But what we have seen in the UAE and elsewhere is that there are also several challenges to effectively establishing and sustaining digital ecosystem. Creating a successful digital ecosystem is difficult and complex. It requires a centralized strategy which prioritizes public-private partnership and coordinate effort to develop digital ecosystem. Despite private company playing the main role in the digital ecosystem development, this coordination is where I believe government can play a role too. First, government can set the tone. by promoting a vision of what digital information will look like over time and articulate key priorities. First, the UAE digital economy strategy did this by laying the priority which we were informed by discussion with industry stakeholders. This signaled to all operating in the UAE that this movement should be embraced and which is going to see long-term government support. And second, a vision must be backed by policies, initiatives, and investment that will facilitate the deployment and executions. And here again, we have been making investment through government and industry in key technology areas such as data analytics and 5G. UAE was the first country in our region and fourth in the world to launch 5G. We also have placed emphasis on AI, including launching of a strategy to become leading nation in artificial intelligence by 2031. These technology areas are essential to creating a digital infrastructure that can properly and securely handle the amount of activity that we expect will take place in the digital domain. Finally, there are a number of areas where government can work with industry and better understand what regulation and policy can be best incentivized investment and deployment of digital technology ecosystem. Especially important will be developing a standard and regulation about the cybersecurity. Perhaps the most daunting challenge is to digital economy is the need to protect network and store data from malicious intrusion. The responses to this threat cannot be piecemeal, given how connected the future digital economy will be. Any weaknesses pose significant risk, making it crucial to set common standards for all operating in the digital economy. The last subject I want to discuss is the issue of talent recruitment and retention, the human capital development. Without that, it's going to be just a dream and a strategy on a PowerPoint presentation. This has gotten more attention in the last year or so as the demand for individuals with IT, data science, analytics, and other technology skill has increased. There will be more demand for individuals with functional skills such as digital marketing and product development, and for leaders who can manage this complex digital ecosystem. Company will have a large role to play in developing the incentive to recruit, retain, and even retrain this in-demand potential. But government can also play an important role. In the UAE, our transition to the digital economy has relied in many ways on potential talent which we can transcend. This means that we need ways to ensure the flow of talented people into our country, including effective immigration law that make it easy for individuals to come to our country and contribute to our economy. In fact, the IMD World Digital Competitiveness Ranking placed us #1 in immigration law. This is just one facet of our approach to building in-country talent. Building digital connectivity into the school is another, as it is creating incentive for a student to prepare for career focus on the development, use, and monetization of key technology driving the digital revolutions. Moving to the digital economy of the future holds great promises for our government, society, and economy. Achieving the promises of this revolution will not be easy, though, and its benefit will not be equally shared. Company will need to embrace the change and think deliberatively but also ambitiously about how they can maximize value by going through the various stages of digitization. First, to improve efficiency of operation, and then to create ecosystem that will offer sustainable new market and revenue stream. This discussion around how the technology, how we can create an agile, not the company, but the country, is absolutely vital. And we are mindful, like my predecessors mentioned, that also technology has some challenges. As we deploy e-learning, blended learning, hybrid learning, integrated learning, there are villages in Africa and other parts of the world that they don't have electricity. Are they going to be deprived from the latest know-how, the latest skills? And we as a human being, as a human race, are indebted for those people, and ensuring that we come up with the technology that all is a sense of inclusion. We are all thinking of everyone, not just an affluent group of people. And that is our human duty. Second, we are now working on, in the companies, to create an entrepreneurship, whereby people want to have a food on the table. They want to have a shelter above their head. So how can we ensure that we create in the company a group of thinkers doing particular job? I mean, we have been importing cars from all over the world, from Germany, US, and we are thinking of creating a company that creates only windshield wiper, nothing else. And once we certify as windshield wiper, all the cars that are imported to UAE will be coming without windshield wiper. So we create jobs. Jobs are not created by mega company. It is SMEs, a small, medium enterprise, that create jobs. I have created in the country, and I'm leading that effort on business accelerator and business incubator, whereby people come to us. This is not new concept. It exists worldwide. People come pitching their ideas, and we provide them with the funding, with the technical mentoring, access to laboratory, and opening doors to sell their product and services. We want these SMEs to become an integral part of bigger boy supply chain as part of business sustainability. I am absolutely honored to be here among you, and thank you for having me, and looking forward to discussion together, inshallah. Thank you.
Thank you, sir. We'll certainly, NICEDT is at the forefront of skilling industry, and we'll certainly look forward of working with you, and discussions will be there on the sidelines of this, how NICEDT can help you in increasing the human capital, the digital economy. Now, as we all know that a technical conference takes lots of efforts, planning. Dr. Yumnam Jayanta, Saurabh Mahanta, others, Dr. Pillai, they have been working very hard, Dr. Manish Arora, and it is because of their unstinted effort we are able to publish an abstract of all the papers. As it was said before, that it's a century and a half that we had did on our debut. So an abstract of all those papers has been, we have prepared, our technical team has prepared, and today is the very right and opportune moment when we are going to unveil that, and I request all our dignitaries on stage to please, it has been placed? To please unveil the abstract. So now with the unveiling of this abstract, I would now request Dr. Imran Janta, Co-Chair, General Chair of this conference, to please deliver the vote of thanks. Dr. Janta, over to you.
On behalf of entire NICEDT, I want to welcome all the delegates on the dais. This conference was coming to this level because of support of all the people. Very shortly, I will list out all the groups that who have held this conference to bring to this level. First of all, I want to thank all the authors. There was around 165 authors. There are some papers were rejected. I also want to thank them because they feel that we can do together with us. So authors are there. Around 200 new members had been included in the NICEDT family from today onward. And there are around 200 reviewers where we have sent the papers to review, and they have happily agreed to do 3, 4, 4, sometimes 5, 6 papers also there. So another 200 reviewers also we have added. And we have our advisors like Professor A.K. Agrawal, Professor S.N. Singh. S.N. Singh sir is also our editor for our Springer lecture note. That is why some of your papers cannot come to the Springer because we have to shortlist something. And I'm very much thankful to Professor Buya, who has joined from the Melbourne. I have been contacting him from long time. We want all researchers, including me, want to have thorough discussion with him because he has two visions. One is for the research, and another one is the startups and the other ecosystem for development of the country. And also I want to thank Dr. Yahya for his time and also the trouble that he has sacrificed all his travel because in the short time he could have he can join us. And I also want to thank M.M. Tripathi sir, our DG. Because of him, because of his suggestion, because of his visionary directions, we could bring to this level. And also want to thank our other committee member, where we have a lot of other committee members, starting from the booking, technical, whole management, the administration led by our registrar sir, and all the fellows. And also especially I want to thank our next invited speakers, where whoever present here, I can simply pass on their name. Professor S.K. Pal, DRDO, is here, and Colonel Inderjit is here with us. Professor G.S. Mani is there, who was the former director of Defense Institution, Pune. Professor Rajiv Kumar, IIT Patna, is here with us. Professor Nilandan Dey is here with us. Okay, maybe, probably. And Pillai sir is also here for delivering one thing. Professor Siddharth Bhattacharya is here. Professor Alak sir is also here, Chancellor of Gazinan Chaudhuri University. Professor Mani Mandurkar is going to join. Mrs. Akansa Sahani is here from IIT Bombay. Professor Santa will be joining in the evening. So these are the invited speakers or the coordinator who are going to join us in all your tracks. Along with this one, this conference is success because of our sponsors group, like our own ministry, Ministry of Information Technology, STPI, EarNet, NICSI, Next Techno, Cube 10 Technology, Institute of Management Studies, IT Pune, and this we have publications partner Springer. We have technical partner in the form of IBM and Society for Data Science Pune. Like this, we have a lot of supporters. I may not mention all the supporters who has been working so hard supporting us from almost 1 year that we are preparing. This was this idea was generated when myself and DG sir was together with Saurabh, we were working in Shillong. We have said that now already we have a lot of things in the skilling and other thing. Now we have to do something in research and development, and so that this can help to reach out to the unreachable side of the entire India also. If you see, NICEDT has 47 centers all over India and 22 centers in the northeast. There are LEDs are embedded there. The purpose of skilling and other thing is that whatever we know, if we can give to our nearby or our juniors or our seniors who don't know this knowledge, that will help, grow the location as well as our own country. So with this, I want to thank all of you for visiting us and supporting us. I think Pata has some announcement. Thank you.
I would take this opportunity to request Dr. M.P. Pillai to present a token of a gesture of love and appreciation to Professor S.N. Singh. Please. I would request Dr. Yumnam Jayanta to please present memento to Professor K.K. Agarwal. I'd request Dr. Ibn Tripathi to present the memento as a token of love and appreciation to Dr. Yahya Al-Marzuki. So with that, we come to the end of the inaugural session, but I would request the esteemed dignitaries on dais to please spare a couple of minutes for a photo op, and then we all break for high tea, though it's pretty late, but tea has been arranged on the first floor. So I'd request all sitting here to please assemble on the first floor for the tea, and I'd request the dignitaries on stage for a photo op. I'd require a group photo of all the dignitaries here, please. यहीं पे डायस में. Where would you like to have डायस? On डायस. Sitting will do, or you want standing? Standing. I request the esteemed panelists who are here to please come on stage so that we can also have a photograph with the dignitaries. Akanksha ji, please. Professor Alok ji, please. Dr. Alok Kumar. But I could recognize you from your photograph. Great. Aye, please. Later on. Tables removed for a height. Ladies first. वो मुश्किल होगा. नहीं. Sir, please be seated. आप बैठिए. अरुण नहीं सर, आप बैठिए. आइए.